This is SpaceTime Series 29, Episode 17, for broadcast on the 9th of February 2026. Coming up on SpaceTime, planet Earth hit by another massive solar storm erupting from the Sun. NASA forced to delay the launch of its Artemis 2 manned moon mission until at least next month. And Beijing announces plans for a Star Wars-style orbital space carrier. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
The Sun has just unleashed a powerful barrage of solar eruptions. Included in the onslaught were some 41 M-class solar flares and at least 6 even more powerful X-class flares, one of which, an X-8.1 class flare, set a new record as the strongest solar flare so far this year. Scientists are describing this as the strongest radiation storm in 20 years, the third strongest geomagnetic storm in 2 decades, the third strongest solar flare of the current solar cycle, and one of the strongest solar wind magnetic fields ever measured. The incredibly violent storm, which lasted almost a week, was generated by a turbulent and fast-growing sunspot region catalogued as AR14366, which was at least 10 times larger than the Earth. Some scientists speculated that this could end up being as powerful as the 1859 Carrington event, regarded as the most powerful solar storm in modern history. Solar flares are classified on a logarithmic scale. There's A, B, and C, followed by M, and finally the most powerful being classified as X. Each of these classes represents a 10-fold increase in energy and is followed by a number, usually from 1 to 9, to provide a more precise degree of strength, although X-class flares are open-ended. The most powerful blast during the current storm, the spectacular X8.1 class event, was exceptionally rare and one of the strongest explosions seen during the current solar cycle. The Sun goes through an 11-year solar cycle, during which time solar activity gets more and more violent as the number of sunspots on the solar surface increases, eventually reaching climax known as solar maximum. That was achieved last year. Sunspots are slightly cooler regions where the magnetic field lines break through the Sun's visible surface from deep below and extend out into space. As they do, they snap apart and then reconnect, triggering powerful blasts of energy known as solar flares. Now, if these blasts are directed towards the Earth, they can reach our planet in as little as 8.3 minutes. Solar flares can sometimes drag clouds of material with them, known as coronal mass ejections, or CMEs. CMEs are composed of ionized gas, including protons, electrons, and atomic nuclei, collectively known as plasma, as well as bits of magnetic field. If aimed at the Earth, they usually arrive several hours to a few days after the solar flare, triggering geomagnetic storms. After solar max, the Sun gradually starts to quieten down again until it reaches solar minimum, when there are often no visible sunspots on the solar surface. It's at this point that the Sun's magnetic poles flip polarity. North becomes south and south becomes north. And then the next solar cycle begins as activity slowly starts to ramp up again. Our current solar cycle, number 25, began back in November 2019, and it should end sometime around 2030. Last week's X8.1 class event sent a powerful surge of X-rays and ultraviolet radiation which rocked the Earth's ionosphere, the charged layer of the planet's upper atmosphere that supports radio communications, and that resulted in strong R3-level radio blackouts. High-frequency shortwave communications were disrupted, especially over eastern Australia and New Zealand, where signals temporarily dropped out. The solar flare was followed by a coronal mass ejection, with shockwaves seen travelling outwards from the site of the flare. However, this CME was fairly weak, with very little effect as it hit the Earth 3 days later. Preliminary models indicate that most of the ejected material missed the Earth, providing only a glancing impact at most. Still, the solar storm did produce some spectacular auroral activity, the northern and southern lights, the aurora borealis and aurora australis. As sunspot AR14366 continued to rotate towards a more direct Earth-facing position, it began to disperse, never reaching the powerful X40 level of the Carrington event, which if it had, would likely have disabled much of today's satellites and technology. Instead, the intermediate part of the sunspot region underwent a significant decay, losing both magnetic complexity and penumbral area. Overall, the active region became more fragmented and less compact, but it's not over yet. At the time of recording, there has been evidence of some resurgence. Also, astronomers have noticed a massive new coronal hole beginning to breach the Sun's atmosphere. Now, these huge dark regions aren't cool spots. They're openings in the Sun's magnetic field, allowing high-speed solar wind to escape directly into space. When one rotates Earth-facing, it can interact with our magnetosphere for days, affecting auroras, satellites, radio and navigation signals, and sometimes even how the atmosphere behaves. Professor Eva Cairns from the University of Sydney says the past week's solar activity, though spectacular, isn't really all that unusual for this period in the Sun's solar cycle.
Well, we've had an active sunspot region or active region moving onto the disk of the Sun facing us, and that region has been evolving. It's been becoming bigger over time, and eventually, perhaps even now, it will start to decrease again. And the magnetic complexity of that region usually increases with time up for a while. And at various occasions, when the magnetic field orientations are correct, it appears as though we get large solar flares, and those solar flares can be in the X-rays or the ultraviolet. And you also get significant radio bursts, microwave bursts, and also energetic particles produced.
What causes a sunspot and solar flare?
What causes a sunspot is that in a plasma or ionized gas, magnetic fields tend to be buoyant. So that if one has just a tube of magnetic force or a set of magnetic field lines running horizontal to the solar surface underneath, maybe there's a little perturbation. One portion of that flat surface gets peaked up, and then that portion tends to be buoyant. And when that region rises up, what was originally a nice horizontal tube now becomes a U-shaped tube with the vertex of the U upwards. And that eventually moves up and reaches the photosphere, that's the visible surface of the Sun, and you then see sunspots, 2 sunspots to be precise, one on each end of that magnetic tube, that U-shaped magnetic tube that goes down deeper into the Sun. And when you have more than one of those U-shaped tubes, the magnetic field lines from those sunspots can be anti-parallel as those sunspots move around. And when they become anti-parallel and close by each other, the magnetic field lines can reconnect by a process we don't fully understand yet, and that basically converts some of the anti-parallel magnetic field line energy into heated plasma and moving plasma. So you get jets of the plasma or ionized gas moving down towards the surface of the Sun and also outwards into the interplanetary medium. And both of those can affect us. The plasma moving downwards will often give us X-rays, and we see then X-ray bursts, which can ionize the upper atmosphere of the Earth, for instance. Whereas the energetic particles can move out into the solar wind and move towards the Earth and impact our satellites. And for instance, if you have a big enough number of those and they're energetic enough, it can charge up a satellite the wrong way and destroy its electronics, for instance. So yeah, these sunspots, when they're, the magnetic field lines, when they're anti-parallel, as I mentioned, some of the plasma moves outwards and some of it moves inwards. And the plasma that moves outwards is usually in the form of you might call it a magnetic bubble with magnetic field lines that close on themselves. And that is a bubble of plasma and magnetic field that moves out into the corona and then the solar wind. And that is a so-called coronal mass ejection. And those can move fast. They can move up to, I think, the fastest ones that people have observed so far are about 3,000 kilometers a second, whereas the slower ones are just at the solar wind speed, and so they're about 300, 400 kilometers a second.
And that's where it gets really interesting when these things reach the Earth. If they're pointing in that direction and they wind up hitting the planet, we get spectacular auroral activity, but it can also cause a lot of problems with technology.
Yes, that's right. And that's due to multiple reasons. One of them is just the solar X-rays and ultraviolet radiation can ionize the atmosphere. the upper atmosphere of Earth, and that ionization also has heating associated with it. And it sort of puffs up the Earth's atmosphere. So the region of the atmosphere that's dense goes a little bit higher up, and that can then impact satellites that are moving through that region because they suddenly see a denser region, and as the particles hit the spacecraft, just slows them down a little bit. It slows the spacecraft down a little bit, and eventually, and it changes the orbit. That's one there's one problem that we have for our technologies, but other ones are perhaps more direct with the energetic particles, the electrons and photons, for instance. When they're above about a mega electron volt of energy, you can get these particles being injected deep into the electronics of our spacecraft. And when that happens, you can get a dielectric breakdown, basically lightning flashes inside the electronics that destroy the chips and the electronic components and render the satellite unable to function. Those are some of the effects, but one of the other ones that I think you're really alluding to or being interested in is when we get magnetic reconnection at the front side of the Earth's magnetosphere. Again, when you've got magnetic fields that are antiparallel, in this case, it's the magnetic field of the Earth versus the magnetic field of the coronal mass ejection. And when that happens, you can get very large changes in the magnetic field and energetic plasma moving into Earth's magnetosphere and into the so-called ring current or radiation belt. And when that happens, you get large numbers of particles bouncing back and forth between the Earth's poles, and they drift around, and as they do so, they carry a current with them. And changes of that current gives rise to changes in magnetic field, which induces electric fields on things like telephone wires and gas line pipes and things like this. And those can give the induced electric fields on power cables, for instance, can destroy transformers and lead to major problems for the electricity grid of a country or a region near where these changing magnetic fields are occurring.
Now, everything you've described up until now is very much 20th and 21st century problems, but it hasn't always been that way. For thousands of years, we didn't have electricity. But then during the 19th century, electricity started to become a thing. Telegraph wires were strung across the United States and Australia. And then all of a sudden in 1859, there was an event, a solar storm from the sun called the Carrington event. And that was pretty famous.
Very famous, yes. And that's an example when we had these large electric fields that I was mentioning induced along telegraph wires, and they were large enough, apparently, that you could have your telegraph turned off, so no power going to it, but you could still send messages back and forth across the Atlantic, for instance, due to, in this case, the power being provided by this space weather phenomenon, this Carrington event. You also had little lightning flashes between the telegraph wires and the ground in many places, which led to forest fires and prairie fires. So it was a spectacular event. And it's actually predicted, a number of people have predicted that if that event occurred during modern times, it would have, as in post about 1980, it would have been large enough to take down the American East Coast power grid because there were relatively few of the large transformers being produced each year. The electricity supply might not have been renewed for approximately 10 years. And you could imagine the consequences of that being catastrophic for the American economy and, for that matter, the world economy. If 1/4 of the United States was without power, the loss in economic activity would be huge, equivalent to a global recession. And the lives of people suddenly without their air conditioners or their heating systems in summer or winter, respectively, would again be, extremely difficult for most modern people to live with.
And we got a bit of a hint of that in 1989, when exactly what you described happened in Quebec, affecting much of the northeast of the United States and eastern Canada.
Yes, that's right. My understanding is that we had a quarter of a million Canadians without power for a number of days, and, similar similar numbers of Americans, but for less at times. It was March, and so relatively cold in Quebec. Yes, that loss of power was difficult for people to live with. It was short term, and it didn't lead to major disruptions in people's lives, but the economic loss was still on the order of $100 million.
The Carrington event would have been the equivalent of an X-40 level solar flare.
Yes, it was a very, very large event, much bigger than any we've yet seen or it's believed to have been much larger than ones we've seen in, for instance, X-rays, and also the speed of the coronal mass ejection, and maybe the strength of the magnetic field in the coronal mass ejection. It's difficult to be precise, though, of course, because we didn't have spacecraft at those times in 1859. And it turns out that, as I understand it, the solar flare was actually observed by Carrington, and it was one of the first solar flares actually observed in H-alpha, in a certain emission line for hydrogen. So it was a very unique event. It was studied a reasonable amount at that time, but much more in the last 30, 40 years. But yes, it's a very large event, believed to have been an extremely large event, and almost, I believe, larger than any we've seen since.
That's Professor Eva Cairns from the University of Sydney. And this is SpaceTime. Still to come, NASA forced to delay the launch of its Artemis II manned moon mission, at least until next month, and Beijing announces plans for a Star Wars-style orbital space carrier. All that and more still to come on SpaceTime. NASA has been forced to delay the launch of its historic Artemis II manned moon mission until at least next month, following fuel leaks during a critical launch dress rehearsal. The leaks, involving the hydrogen tanks aboard the massive 98-metre-tall SLS Space Launch System rocket's first stage, developed just hours into the fueling operations, ahead of what should have been a wet launch dress rehearsal in advance of the flight. Artemis II will carry a crew of 4 aboard an Orion spacecraft on a 10-day journey around the moon and back from Space Launch Complex 39B at the Kennedy Space Center at the Cape Canaveral Space Force Base in Florida. And when it does happen, it'll be a long-awaited historic journey. You see, NASA last sent astronauts to the moon during the Apollo program of the 1960s and 70s, and the last humans to walk on the moon were those of Apollo 17 back in 1972. The new Artemis program aims to set the stage for a permanent human presence on the lunar surface, including a new space station in cislunar orbit. It'll provide a jumping-off point for eventually sending humans on longer missions to Mars and beyond. Artemis II will test key systems aboard the Orion spacecraft, including its maneuverability, its docking capabilities, life support and radiation protection systems. A number of experiments and the deployment of 5 satellites will also take place during the flight, which will travel more than 6,500 kilometres beyond the moon, in the process making this journey the furthest humans have ever travelled from Earth. Splashdown will be in the North Pacific Ocean off the California coast. Artemis II will be followed by the Artemis III mission. That's the big one, which will return humans to the lunar surface, landing near the moon's south pole. The Artemis II wet dress rehearsal involved loading 2.65 million litres of cryogenically cooled liquid hydrogen and liquid oxygen into the rocket, and then proceed with mimicking the final stages of an actual launch countdown, with automated systems taking control of all countdown operations, final checks of flight computers, engine bleed systems operational, and ground support equipment running as the rocket transitions to internal power and the countdown proceeds towards a simulated engine start. However, excessive hydrogen quickly built up near the base of the launch vehicle. That forced mission managers to halt fueling at least twice as the launch team scrambled to try and resolve the problem. Now, hydrogen is a highly efficient propellant for rockets, but its molecules are so tiny and light they can easily escape even the tightest of seals. Attempts to resolve the issue involved stopping the flow of liquid hydrogen into the core stage, allowing the interface to warm up for the seals to reseat, and adjusting the flow of the propellant. The same issue developed during the Space Launch System countdown for the unmanned Artemis I mission, which travelled around the moon and back to Earth back in 2022. Cryogenic hydrogen and oxygen are also the fuels used on the space shuttle program, so finding a repeatable workaround must be possible. But the leaky hydrogen seals wasn't the only problem. Other issues encountered during this wet dress rehearsal included several radio communications dropouts, something that also happened in the weeks leading up to the exercise, and problems with the cameras aboard the spacecraft due to cold weather. And there was also a sticking valve on the Orion spacecraft crew module hatch pressurization system, which had to be replaced and then retorqued. That resulted in the closeout operations, which ensure Orion is secure and ready for crew ingress, taking much longer than planned. The mission had already been delayed several days by freezing temperatures at the launch pad site, not to mention more than a dozen delays during the developmental phase of the program. Mission managers have now slated another launch attempt in March, with 5 launch windows available during the month on the 6th, 7th, 8th, 9th and 11th. Now, if the mission can't make any of those dates, another window opens on April the 1st, with alternatives between April the 3rd and the 6th, and again on April 30th. This is SpaceTime. Still to come, Beijing unveils plans for a futuristic Star Wars-style orbital space carrier capable of raining hypersonic missiles and unmanned stealth drones down on its enemies. And later in the science report, China announces the development of a new satellite killer energy weapon. All that and more still to come on SpaceTime. This episode of SpaceTime is brought to you by Squarespace, your all-in-one website builder that makes it simple to create, share and grow your presence online. Now let's talk about one of our listeners, Emma. She's a science communicator who started hosting small science workshops at her local community hall. But when word started to spread, she knew she needed a professional online presence and she needed it fast. And that's why she turned to Squarespace. Emma built her website in just one weekend. With Squarespace's easy tools, she listed her upcoming events and let people book tickets online. No awkward email chains, no manual payment schemes. The built-in scheduling feature sent out automatic confirmations, and she even used Squarespace's email marketing to remind attendees about new events. Everything looked clean, on brand, and totally professional. Emma started with Blueprint A1. She then customized it using an award-winning template, dragging and dropping content until it matched her vision for a modern, sleek science hub. And here's the kicker, people started finding her site straight away through Google. You see, Squarespace's SEO tools were working quietly in the background. If you're ready to create your own story, go to squarespace.com/spacetime for a free trial. And when you're ready to launch, use the promo code SpaceTime to save 10% of your first purchase of a website or domain. That's squarespace.com/spacetime with the code SpaceTime, and you'll find the link in our show notes.
You're listening to SpaceTime with Stuart Gary.
Beijing has unveiled plans for a futuristic Star Wars-style orbital space carrier. The giant space plane would be designed to rain hypersonic missiles and unmanned stealth drones down on its enemies. Called the Luanio after a mythical Chinese bird, the massive triangular spacecraft would be more than 242 metres long, 684 metres wide, and weigh up to 120,000 tonnes. That's more than an aircraft carrier. China's state broadcaster CCTV, which broke the story, says the spacecraft would carry 88 unmanned Wannu or mysterious woman fighter drones capable of operating in near-Earth space or the upper atmosphere. The colossal flying aircraft carrier would be part of an ambitious air and space defense system called Nantianmen or Heavenly Gate. The plan remains purely science fiction for now, as no nation, including China, has the technology to build such a weapon, at least not yet. But it does provide an insight into Beijing's current thinking and long-term plans. The story comes as the United States accuses China of conducting a secret underground nuclear test, claiming Beijing used advanced technology to try and conceal the explosion. US President Donald Trump says the clandestine test, which occurred in 2020, was designed to help its close allies Iran and North Korea. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. China has announced the development of a new satellite-killing energy weapon. Beijing says it's commenced production of a 20-gigawatt microwave weapon capable of firing 60-second bursts that can destroy satellites in low Earth orbit, including Starlink's broadband internet satellites. The key here is the new weapon's been miniaturized down to just 4 meters long, weighing less than 5 tons. Now, that's just not small enough to be mounted on a warship, aircraft, or even a hunter-killer spacecraft. It's small enough to be placed on the back of a truck. The Communist government says testing has confirmed that its new TPG-1000C variant can fire several thousand pulses in a single 60-second burst, producing enough energy to destroy orbital spacecraft. The Doomsday Clock has moved closer to midnight. The clock, developed by the Bulletin of the Atomic Scientists, provides a measure of how close civilization is to human annihilation. The latest adjustment, 85 seconds to midnight, marks the third time in 4 years that scientists have been forced to tick the clock towards catastrophe, and it's the latest in more than a decade of steady advances in that fateful direction. The Bulletin warns that since 2020, humanity has moved closer to the precipice than at any time during the Cold War arms race. Threats of nuclear war by the Kremlin and Tehran, as well as China's threat to invade Taiwan next year, are the primary concerns, compounded by the growing problem of climate change and the dangers posed by artificial intelligence and disinformation campaigns. The Bulletin of the Atomic Scientists, which was founded by nuclear scientists led by Albert Einstein and Robert Oppenheimer in 1947, was initially set at 7 minutes to midnight. A new study has shown that extreme hot and cold temperatures are sending thousands of Australians to hospital emergency departments every year. The findings, reported in the Australian and New Zealand Journal of Public Health, shows that 1 in every 15 emergency cases are now linked to extreme weather. The study's authors analysed historical weather and hospital emergency department data for Canberra and say that nearly 36,000 visits between the year 2000 and 2021 were linked to heat, representing 1 in 40 or 2.5% of all hospital visits. They project that heat-related visits in Canberra alone could increase to 90,000. That's 2.7% of all emergency department visits between 2040 and 2061 as the climate continues to warm. Interestingly, they also found more than 57,600 emergency department presentations in Canberra, that's 4% over the 2 decades analysed, were linked to cold weather conditions. The authors say that while the share of cold-related visits is expected to fall as winters warm, cold exposure is still projected to drive over 81,000 visits between 2040 and 2061. For years now, conspiracy theorists have been warning society about secret government projects designed to spread chemicals into communities using high-flying aircraft. The idea of chemtrails probably originated with cloud seeding experiments to encourage rain in drought-affected areas. Or maybe it was the use of Agent Orange defoliants during the Vietnam War. Or maybe even earlier, to a time when crop dusting first began. Whatever the original source, chemtrail conspiracies are a real thing. And as the skeptic's Tim Mendham points out, it's not going away. That's despite a complete lack of any scientific proof.
Chemtrails are based on the idea of contrails. Contrails are the water vapour you find behind a jet when it's travelling through certain atmospheric conditions, certain speeds. Chemtrails are suggesting that it's not water vapour, it's actually chemicals being put into the atmosphere for some nefarious purpose. And you start to wonder straight away what the purpose is. But before they look at purpose, they have to look at, is it happening at all? The theory that's been around for a while, a number of decades, probably since the mid-90s, that for some reason these chemtrails are being put into the atmosphere, and it might be that in certain places there's a lot of aircraft, so there's a lot of contrails around in the sky, and they think, what are all those contrails doing? Well, because you've got a lot of planes. And a lot of the contrails last for a while. They don't necessarily disappear straight away. Some do, some don't. And the idea is that these things that do stay must be something in them to make them, to give them that longevity. It's totally unfounded. There's a lot of people giving credence to that the government's out to get them. They hate government. What they are trying to do with these chemtrails, what the government's nefarious activities, is pretty unknown. I mean, in all sorts of suggestions, they're supposed to wipe out life. You sort of think, why? It's not going to do a government a lot of good. And other things that they will make people infertile. You think, why? It's a population control measure. Okay, surely you should be doing it in places with a bigger population growth than Western countries like the USA. And then it's just, it's brought about by people having just a fear of the unknown, a fear of ambiguity, and they need some sort of certainty. They see something in the sky, they see what they think is a chemtrail, chemicals being poured in the atmosphere, and they have to find an explanation for it. They might think this is the explanation, but then you have to look at the reasoning and you think, it's interesting because I looked at a long article recently that came out looking at chemtrails and the belief in it. They never once actually say what's supposed to be happening to these things. And it'll be pretty important to think, well, what's the impact of this thing? Why are they doing it? They're just a conspiracy theory that the government's out to get us. The reasons being put forward are pretty shallow. There's also a lot of people involved in it who are now suddenly scientific experts who have no scientific background whatsoever. There's a famous guy who had claimed to have, was a contractor to a big engineering company, that he had electrical experience. He was actually a solar panel installer without any scientific qualifications at all, but that didn't matter. He suddenly becomes an expert. There was another guy who used to inspect septic tanks, and he became an expert. So, people are claiming engineering backgrounds, CIA associations that they don't have largely. So that's the initiators. Probably you get more people now, obviously, politicians and people in government are believing in chemtrails, but a lot of people in the American government also believe in UFOs and stuff like that, and the evidence just ain't there.
That's the Skeptic's Tim Mindham, and this is Space Time. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.